All right, folks, today we're going to talk about the quadratic formula. The quadratic formula, as you might know, is in this particular style. X equals negative b plus or minus the square root of b squared minus 4ac. Now, of course, if you know the song Pop Goes the Weasel, you could then sing it. Let's try it. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. Big cheers all around. Yay! All right, so first thing you want to do, make sure it's in standard form, if necessary. If it's not already equal to 0, oh, I forgot that. I need to make sure it looks like equals 0. Okay, we don't really need a y equal on this because this is just going to be a quadratic equation, not a quadratic function. All right, and we're trying to solve for the zeros. All right, so we name our a, b, and c. Based on that, those will all be integers. There won't be any variables in there. Substitute into the quadratic formula, being careful of signs. Here's that formula again. Okay, the next thing we'll do is to simplify carefully, finding the square roots or breaking it down by the simplifying square roots approach. Next, we want to go ahead and break into positive and negative square roots. And lastly, find two solutions if possible. Now I'll do a quick example for you based on this. If I started with something along the lines of x squared minus 6x plus 8 equals 0. All right, that's already got the first step. So our second step here, if there's no number, a would be 1, b would be negative 6, and c would be 8. Now my formula tells me I'm going to go, and I still have it up there, I'll follow that. I know that I'm going to start with x equals negative 6 plus or minus the square root of negative 6 squared minus 4 times 1 times 8 all over 2 times 1. Okay? So in simplifying this, which is basically my step 4, what I'll do, I'll go ahead, I know negative 6 is positive 6, plus or minus the square root of negative 6 squared is not negative 36, but positive 36. Negative 4 times 1 times 8 is minus 32, all over 2 times 1, or 2. All right, let me take a minute and take care of this. I know that answer equals 4, and the square root of 4 equals 2. So in breaking this down, I will then know that I'll have 6 plus 2 all over 2 is my positive root. My negative root will be 6 minus 2 all over 2. I'll simplify that. That's 8 over 2, or 4 is one solution. That's 4 over 2, or 2. So for this one, I would say x equals 4 or x equals 2. All right, so that's a nice use of it where we have rational answers. Now in here, I'm going to look at a few different circumstances. I want to look at A, if I have 2 rational roots, B, if I have 1 rational root, C, 2 irrational, and D, no real roots. So I've given one example of each. I've copied my equation up there, so I'll be able to run that through. So just like before, I know A equals the x squared, which once again, I don't need y equals, I need it equal to 0. A equals 2, B equals 7, C equals 3. So I'll plug it in, negative B, which is negative 7, plus or minus the square root of b squared, which is 7 squared, minus 4 times 2 times 3, all over 2 times 2. Okay? That becomes negative 7 Let me rewrite that slightly, make the colors a little bit different. Negative 7 plus or minus the square root of 49 minus 4 times 2 is 8. 8 times 3 is 24. So minus 24 all over 4. Now I know this answer is a square root of 25, which gives me the number 5. So in doing my roots, I'm going to have my positive root as negative 7 plus 5 over 4. And my negative root will be negative 7 minus 5 over 4. I'll get my two answers. Here I have negative 2/4, which is negative 1/2. I have negative 12 over 4, which is negative 3. So two real roots. Now let's look at what happens for one rational root. Once again, I want to make sure it's equal to 0. It already was, I just set it up wrong. Okay, so A was positive 2, B is negative 12, C equals 18. All right, so I'll start with negative 12 plus or minus the square root of negative 12 squared minus 4 times 2 times 18. All right, all over 2 times 2. All right, let me move up here. And now I'll have, all right, it becomes 12 plus or minus the square root of, now 12 squared is 144. 4 times 2 is 8. Now 8 times 8 happens to be 144. All over 4. Now when I go to deal with this, I now know that this is equal to 0. The square root of 0, of course, is just 0. So what I've got is 12 plus or minus 0 over 4, which of course will just be 12 over 4. So in this case, I'm just going to get one real root. So that root is 3. All right, in my third circumstance, I'm going to look at what happens with two irrational roots. Here, A would be negative 2, B would be 6, C would be negative 7. I'll plug it in and see what I come up with. I have negative 6 plus or minus the square root of 6 squared minus 4 times negative 2 times negative 7. Okay? All right, now here it looks like, actually, I'm not going to get irrational roots. I'm going to get a whole different kind of answer. 2 times negative 2 in here. So when I go to simplify this group, I'm going to get negative 6 plus or minus the square root of 36. And I got a negative times a negative times a negative, so I know it's going to be subtracting. 4 times 2 is 8. 8 times 7 is 56. All over negative 4. Now when I go to deal with the discriminant here, I'm going to get the square root of negative 20. Now I can stop right there and say, hey, this is not going to give me a real solution. So this would be no real roots. Okay? So what I want to do is to take, so I've messed up on this one, so let me look at D. I'm going to change this D. Instead of saying it is it's going to be minus 9. I mean, instead of plus 9, let me change this equation to minus 9. And I'll put a little equal 0 next to it. And I don't really want a y equal there at all. All right, so let's see how this last one works out. Okay, here I've got A as being 3, B is negative 5, C would be negative 9. So what I'll do for this one, x would equal to negative 5 plus or minus the square root of negative 5 squared minus 4 times 3 times negative 9 all over 2 times 3. Let's simplify this down. I've got 5 plus or minus the square root of negative 5 squared is 25. Now I have negative times negative, which is positive. 4 times 3 is 12. 12 times 9 would be 108. Okay, I could have also done 4 times 27 and gotten the same answer, all over 6. Now to continue this, I'll work my way down, and let me take care of the discriminant here. I've got 25 plus 108. That happens to be the square root of 100 and let's say 30, I believe that's going to be 33. And I don't think that has any roots at all. So I have a couple ways of writing my answer. The first way is simply like this. 5 plus or minus the square root of 133 over 6. And in some cases, we can leave the answer like that. Now, in a lot of cases, I'll go ahead and branch it out. I'll branch it out this way just for simplicity. 5 plus root 133 over 6. And then for my negative root, 5 minus the square root of 133 over 6. And depending on the situation, in some cases we can leave the answer like that. In other cases, we might want to go ahead and find an approximation for that. So let me view my scientific calculator here, because I want to do here is to go ahead and find out what this is going to be. Okay? So first I want to find the square root symbol on this crazy little calculator. So I've got basically the square root is to the 1/2 power. And so looks like I'll go ahead and do, I think the way I would do that is 2 root of 133. They're saying that answer, no, that's not the right one. Okay, I'll try it like this. 133 to the power of 0.5, 11.53. Okay, so I'll add 5, and I'll divide by 6. So one answer is approximately 2.76. Okay, and my other answer for this, we'll do the same basic process. And this time, I'll try it like this. I'll type in 5, and I'll subtract 133 to the power of 1/2. Okay, and I get negative 6.53. Divide that by 2. That gives me approximately 3.27. Negative 3.27. All right. I know that's going to be approximately correct because the square root of 121 is 11. So it's kind of close to that. Let me check one more thing. In case I did it wrong, I'm going to try another technique that might help me with this. I'm going to go ahead and get these, clear everything out, because you can't always trust some of the answers you get first time. 133 to the power of 0.5. Okay, 11.53. Okay, now I'm going to subtract 5. Actually, I'll change that to negative, and I'll add 5, get that answer. Divide that by 6. Negative 1.08. That looks a little closer. It's actually negative 1.09. All right. So this is an example of two irrational roots. Whole numbers, but they don't have a very good, you can't make that into a fraction. Now the last thing is talk about the discriminant, which are these same kind of things we just did, okay? It's based on this idea, which is inside our square root. That determines our type of answers. If it's a positive number, which is the kind we like, you get two real roots. If it is equal to 0, you get one real root. Finally, if it's a negative number, you get no real roots. Okay? I'll try to give you an example of each. If we have x squared minus 4x minus 8 equals 0, my discriminant is just going to be b squared, or negative 4 squared minus 4 times 1 times negative 8. So I have 16, negative times negative is positive, plus 32. I get a positive number 48. So I know I'm going to get two real roots. All right, now let's try another one. This time, let's do something along the line of x squared minus 6x plus 9 equals 0. All right, negative 6, or b squared, excuse me, negative 6 squared minus 4 times 1 times 9. 36 minus 36 equals 0. One real root. All right, now lastly, let's try one with no real roots. And let's say I have 2x squared minus 3x, and I'll say plus 10 equals 0. B squared would be negative 3 squared minus 4 times 2 times 10. 9 minus, because we don't have any other negatives, 4 times 2 is 8. 8 times 10 is 80. And that would be negative 71. So you'd say no real roots. Okay, thank you very much.